Hello, Algebra 1 students. Here we are in Unit 6, Tier 2, Lesson 2, Solve by Substitution. Let's check off our booklets. Here we are in Lesson 2 of Tier 2, Solve by Substitution. Sometimes when using the substitution method, we will have to substitute a binomial expression. When doing this, in most cases, the distributive property will need to be used to simplify. Also, if you have two expressions set equal to the same variable, set the expressions equal to each other and solve for the other variable. Lastly, once one variable value is found, plug that value into one of the original equations to find the other variable. And we've kind of already done that a little bit in the previous lessons, but now we're going to really get into doing this. All right, so let's come down here and look at the first example. This is a binomial, okay? All that means is there's two terms in the expression that is equal to the variable. All right, so let's plug it in. We have 3x plus 2 and y equals this whole thing right here. So we're going to plug that whole thing in there, 2x plus 3. And then equals 13. Well, now we got to use our distributive property. So we get 3x plus 2 times 2x is 4x plus 2 times 3 is 6 equals 13. Now we must combine our like terms, which are 3x and 4x. So we get 7x plus 6 equals 13. We're going to subtract 6 from both sides because we're isolating our variable. We get 7x equals 7. We're going to divide both sides by 7, and we get x equals 1. I'm going to shrink this down. And now that we have x equals 1, we want to pick either equation 1 or equation 2 to plug that back into. It doesn't matter because those are the two original equations. I'm going to pick the first one because y is by itself, so whenever I plug x in, it's just going to give me what y equals. So I'm going to have y equals 2 times x, which is 1, plus 3. So we have y equals 2 plus 3, which is going to give us y equals 5. I'm going to shrink this. So then our ordered pair for this would be our x value is 1 and our y value is 5. So the solution for this linear system is 1, 5. Now I'm going to go up here and talk about this other example when you have two linear functions in a system that are equal to the same variable. See how these both expressions are equal to y? This is when we're talking about this part of the notes, when we have expressions set equal to the same variable. So all we have to do is set these two expressions equal to each other, because if this equals y and this equals y, then you know that those two things are equal to each other. So 3x minus 3 is equal to 5x plus 7. Now all we have to do is simplify this equation and solve for x. So I look at it like, if you remember from the solving equations yellow booklet, I looked at see which side has the more x's. Well, this side has 3 and this side has 5. I don't like dealing with negatives, so I'm going to move the 3x to the right. And I'm going to do that by subtracting 3x from both sides, balance point. So I get negative 3 left over here because these cancel. And I get 5x minus 3x, which is going to equal 2x plus 7. Now I'm going to move the 7. These cancel, so I'm left with 2x on this side equals negative 3 minus 7 is a negative 10. And then lastly, I'm going to divide both sides by 2. And I'm going to get my x value as negative 5. I'm going to shrink this down. Now that I have my x value, now I just have to choose which of the two equations 1 or 2, to plug it in. Well, I think I'm going to put it into the equation 2 only because the numbers are smaller, so it'll make my multiplication a little easier. So I'm going to have y equals 3 times negative 5, because negative 5 is going in for the x right here, minus 3. Well, that's going to give me y equals, 3 times negative 5 is negative 15, minus 3. So y is going to equal negative 18. My solution for this linear system is going to be negative 5 for my x value and negative 18 for my y value. Good luck on your practice sets.